Hi everyone, welcome to my channel. Today we're going to discuss with you the new DP Biology course, Theme A, Unity and Diversity, Organization Molecules 1.1 Water. Before diving into our topic, let's see what are the standard and higher level learning outcomes. Now, these learning outcomes are very important to keep you on the track and understand what is important points on this topic. And it's very important for your examination. Just remember this one. Next comes the guiding questions that we're trying to answer over the course of this topic. So, what physical and chemical properties of water make it essential for life? And what are the challenges and opportunities of water as a habitat? At the end of the lesson, you have to answer these two questions. Now, we know that the water is a very important part of our life, and 71% of Earth is covered with water. And it has estimated that water has existed in our Earth 3.8 billion years. And first cells evolved in water, and the oceans blocked the harmful ultraviolet radiation coming from the sun and helped the life emerge on Earth. Now, water as a medium for life. Water is the solvent that makes up the fluid in all cells where all cellular reactions occur. It makes up the fluid inside all organelles and cells. It permits transport of substances into and out of the cell, and essential to blood and many other blood fluids in human and other organisms that provides the medium in which all organisms in oceans and lakes and rivers live. Before talking about the properties of water, let's just revise the chemistry lesson, bonding. So let's see what are the difference between the ionic and the covalent bonding. So ionic bonding occurs from the electrostatic attraction between oppositely charged ions in a chemical compound, and ionic bonds essentially donate an electron to other atoms participating in the bonding. Whereas covalent bond is the sharing electrons, and it could be equally sharing or unequally sharing electrons. So although we define covalent bonding as an electron sharing, the electrons in a covalent bond are not always shared equally by two bonded atoms, such as in polar covalent bonding. So there's always be one atom that attracts the electron in the bonding more strongly than the other atom, and such imbalance occurs on one side, results in a buildup of a negative charge, and the other side builds up in a positive charge, which creates the polar covalent bonding that there's an unequally shared electrons. What about the nonpolar covalent bond? Is the bonding electrons shared equally between two atoms and no charges on atoms, such as chloride molecule. When it comes to the structure of the water, so we know that the water is a polar molecule, and it's unusual for pure covalent bonds to exist between atoms of different elements. Usually one of the atoms involved in the covalent bond will be more electronegative and will have a greater attraction for the bonding pair of electrons. A polar covalent bond is a bond formed when a shared pair of electrons are not shared equally. Because in the water the oxygen atom has more protons, it attracts the shared electrons more of the time, creating an unequal distribution of the charge. So in water, a single oxygen atom is bonded to two different hydrogen atoms. Each oxygen-hydrogen bond is a polar covalent bond, and this results in a single negative charge at the oxygen end of the molecule and slight positive charge at the end of the two hydrogens. Because of the open triangular shape rather than the linear shape of the water molecule, the two ends of each molecule have opposite charges. So oxygen, a water molecule, the 8 protons in the nucleus of the oxygen atom have more pull on the shared electrons. Now, hydrogen bond in water is a dynamic attraction between neighboring water molecules involving one hydrogen atom located between the two oxygen atoms. Each water can form hydrogen bonds with up to 4 other water molecules. Remember here that the water, hydrogens, and oxygen are bonded with each other with covalent bonding, whereas water molecules with each other are binding with hydrogen bonding. Let's see the properties of the water molecules. First comes the cohesion of water molecules. So cohesion is the force by which individual molecules of the same type attract and associate, like stick together. Water molecules stick together because of the hydrogen bonding, and these bonds continually break and reform with surrounding water molecules, although at any one moment a large number are held together by their hydrogen bondings. And cohesive forces allow water molecules to be drawn up by xylem vessels in plants by the evaporative loss of water from the leaves. Surface tension is when the outermost molecules of water form a hydrogen bond with the water molecules below them, as you see in the diagram. This gives water a very high surface tension, and this surface layer, held together by surface tension, creates a considerable barrier between the atmosphere and the water. In fact, other than the mercury, water has the greatest surface tension of any other liquid. And there is the example of surface tension. Walking on water, such as small insects in the water can walk on water, such as the water strider, and the careful placed small needle can be made to float on the surface of water even though it's several times as dense as water. Washing with the cold water, the major reason for using hot water for washing is that its surface tension is lower and it's a better wetting agent. And the surface tension of water provides the necessary wall tension for the formation of bubbles with the water. Adhesion is when water molecules stick to other substances. This is what allows water to move upward through a plant against gravity. Water clings to the side of the plant's veins, and this is called the capillary action. Water as a solvent, we talked about it that water dissolves more substances than any other liquid, and polar molecules will dissolve in water because they are hydrophilic and can form hydrogen bonds with water. What is hydrophilic and hydrophobic? Hydrophilic is that any substance that has an affinity for water, like it likes water. What about the hydrophobic is that any substance that does not have an affinity for water. Now, water is a good solvent for charged and polar substances such as amino acids, peptides, small alcohols, carbohydrates, and water is a poor solvent for non-polar substances such as steroid hormones and cuticles and oils. And the cytoplasm is a complex mixture of dissolved substances, and it's an aqueous solution because the solvent is water. And the solutes in this aqueous solution can move around and interact, and many different chemical reactions are catalyzed in the cytoplasm that is all collectively known as the metabolism. Substances can be transported as an aqueous solution in both plants and animals, and the plants have such two transport systems. Mineral ions are transported through xylem sap, sucrose and other subproducts of photosynthesis are transported through the phloem sap. Sodium chloride is an ionic compound that is freely soluble in water, which is transported in blood. Amino acids, glucose, and water, they're all soluble in water, so they're also transported by the blood to different cells. Now, physical properties of water. There are three physical properties of water. It's the buoyancy. There are four physical properties of water. It's the buoyancy, viscosity, thermal conductivity, and specific heat capacity. Now, viscosity is a measure of the material's resistance to flow. In other words, its thickness. High viscosity fluids take longer to pour from a container than low viscosity fluids. When an object is immersed in a fluid, the fluid exerts an upward force on the object. This phenomenon is known as buoyancy, and the upward thrust is known as the buoyancy force. Characteristics of buoyancy is that it determines whether an object will float or sink. Example of the viscosity and buoyancy is that the black-throated loon can swim large distance underwater. However, Bird anatomy had adapted for life in the air and on land, with hollow bones that decrease weight and the air trapped between feathers to provide the insulation. These adaptations can be problematic in water as buoyancy needs to be overcome to catch underwater prey species. The loon has solid bones to increase its weight and to compress air from its lungs and feathers to decrease buoyancy and enable successful diving. Fat is stored in animals as adipose tissue, usually under the skin, such as subcutaneous fat, and aquatic diving animals, such as seals, have a great deal of subcutaneous fat, which is known as blubber. Blubber acts as a buoyancy aid as well as providing thermal insulation. The seal uses its nippers to propel itself through the water. The black-throated loon has webbed feet that provide a large surface area to push against water. The feet are located laterally and toward the back end of the body to allow maximum propulsion. The specific heat capacity, the amount of heat required to raise the temperature of a substance by 1 unit is called the heat capacity. Water has a much higher capacity for storing energy. A relative small amount of water absorbs a great deal of heat for a corresponding small temperature rise. So as you see in the picture, in order to raise 1 Celsius degree of 1 kilo of glass, you need 840 joule of heat. Whereas for water, it takes 4200 joule of heat. That is the specific heat capacity which allows living organism to dwell in water. And thermal conductivity, the rate at which heat passes through a material is known as thermal conductivity. Water has relatively high thermal conductivity, and water is useful for transferring heat from parts of the body where it is generated and parts that need more heat or dissipate excess heat to the environment. Water has a high thermal conductivity than air, with water conducting heat 28 times better than air. By trapping air in its feathers, the black-throated loon forms an effective insulating layer between its skin and the outside air. Feathers also restrict convection currents by trapping a thin layer of air that's not able to move easily. What about the origin of water on Earth? There are competing hypotheses for the origin of the vast amounts of water on Earth. The most widely supported hypothesis is that water was delivered to the Earth by colliding asteroids. Currently, large asteroids collide with the Earth about once every 20 million, and this rate of bombardment could not account for all of the water on Earth. However, there is an evidence of much heavier bombardment during the first few 100 million years after Earth's formation. Asteroids that have been in orbit for a billion years have lost nearly all of their water due to the heat from the sun evaporating water and gravity being too weak to retain water vapor. Two facts are important on how water retained on Earth. First is the distance of the Earth from the sun ensures that the sunlight never raises temperature high enough for water to boil. And the second is due to its size. The Earth has relatively strong gravity, holding the oceans tightly to its surface and holding gases within the atmosphere. The search for extraterrestrial life. Water, atmosphere, and magnetic fields that protect from harmful ionizing radiation are necessary conditions for a planetary body to be classified as being in a Goldilocks zone. Our galaxy is the Milky Way that has 100,000 million stars. Any planet that could be possibly support life must have water, and that planet must exist in an area of its solar system that would allow water to exist in its liquid form. This position of Earth in relation to Sun is called the habitable zone or Goldilocks zone. Revisited here, what physical and chemical properties of water make it essential for life. In this chapter, we have described how and why water has polar covalent bonds due to unequal sharing of electrons between oxygen and hydrogen, cohesive forces attracting one molecule of water to another, adhesive forces attracting molecules of water to other types of polar molecules, and excellent solvent properties of water. So, second question is, what are the challenges and opportunities of water as a habitat? Is the buoyancy, which is important to all aquatic and semi-aquatic organisms to keep them at or near water surface. Viscosity, the body shape and propulsion mechanism of animals that have become adapted to overcome this resistance that water has for object moving through it. Thermal conductivity. Organisms living in a cold water environment must have either a physiology adapted for water temperature or a mean of insulation. Specific heat. Water in oceans, lakes, and rivers has a very high specific heat that protects many aquatic organisms from much colder surroundings and air temperatures. For HL, how water is necessary for life, and very few planetary bodies possess the conditions necessary to retain water. Surface temperatures must allow water to exist in liquid form, and sufficient gravity must exist to prevent water from escaping. So that's it for today, guys. Now, don't forget to subscribe to my channel and follow me on social media. Bye bye.